So, good day, good evening. Welcome to the May edition of the OpenLineage monthly TSC meeting. As a reminder, this meeting is being recorded and the recordings are being uploaded and archived to our wiki and to our YouTube channel. Thank you, Shiri. We usually like to start the meeting with roll call of everyone who's attending the meeting. So on my screen, starting from Shiri. Do you want to say hi?
Yes, hi, I am Shiri Cabral. I am on the technical steering committee for OpenLineage, and so that's why I'm here to keep up to date with what's going on in the OpenLineage world.
Shiri, next up is Maciej.
Hi, I'm a software engineer at Datadog and a TC member, and I will have a short update on async HTTP client.
Thanks, Maciej. Next on the list is Michael.
Hey, Michael Colato, software engineer at Snowflake, TSC member. And I'm going to talk, I'd like to talk a little bit about the Polaris and OpenLineage integration. Again, I think I've mentioned it before, but we actually have some traction going.
And thanks for joining. I know next week is a busy week for everyone there.
Yeah, big week.
Excited for the news there. Last but not least, Julian.
Hi, I'm Julian. I'm also at Datadog. I come in to listen in and keep up to date with the project. Unfortunately, I have a conflict for the second half of the meeting, so I'll disappear halfway. Sorry about that.
And I'll go last. I'm Harel. I'm engineering at Datadog. And I'm also TSC member, and I will facilitate today's meeting. All right, so reminder, you can find us on the interwebs in a bunch of places. So we have a pretty light agenda, which should leave us time for open discussion. We'll go through a few quick announcements, highlight some things from recent releases, and then we'll go into the discussion. So one announcement to make is last week, Pavel from Getting Data presented at Current 2025 in London. That's the Confluent conference, presenting about native data lineage support in Flink. With OpenLineage, there's a lot of really great progress that's been happening on the Flink side. Very exciting. Thank you to Pavel. Pavel is also, of course, a TSC member, a long time committer on the project. And the other announcement is in a couple weeks, Maciej and myself will be presenting at Datadog's developer conference in New York about data observability and how OpenLineage fits in. If you're in New York, you are very welcome to join us. All right, from here, quickly going through recent releases. So we've been busy. Thanks to all the contributors from the community. So thanks to Peter for shipping enhanced JDBC extractors, basically adding more additional types. We said goodbye to Python 3.8, and the officially supported version is 3.9 plus. Thanks, Maciej, for keeping us sane there. And then we changed the way that partition keys are generated for Kinesis, the Java client. I will not go through all the fixes, but there's a bunch of fixes. You'll see them throughout. Quick follow-up version on that is adding schema facet for Avro datasets. Thank you, Pavel. And also a static utility or a utility for generating static UIDs. Thank you, Dolphinus. Again, a bunch of fixes in DBT and Flink and Spark. And the latest release, so we've added the transform transport for the Python client. So the transform transport allows you to mutate objects as they move over, useful for a bunch of use cases. We've added a catalog dataset facet. This might be something that you're interested in, Michael. So and also the implementation of it for Spark should be an interesting discussion. First time committer, Shin Abel from Amazon. Thank you for adding a transport layer for Amazon Data Zone. And Casper, some modifications on the run facet, on the parent run facet, excuse me. Okay, then again, there's a bunch of changes and fixes in Spark and DBT and Flink as well that we will not go through. So from here, we can jump into the presentation that Machi is prepared. Do you want me to skip slides for you?
Yeah, it's just a couple, and we can do this way. So I can start with the next slide. Well, let's define what problem I want to talk about. And OpenLineage is an event-based specification, and the basic definition is that when we start a run and finish a run, whether it's a successful or unsuccessful run, we emit an event. This is like for bad jobs. For think we have a running job that type that acts kind of like a heartbeat and updates some information during, but the basic model is 2 events per run, right? And those are fairly small, fairly large jobs and fairly small events. So the like performance and throughput was never a big issue in case of this HTTP client. Since like Airflow job can take several minutes or even hours, sending 2 events is not a big problem, right? But then we have DBT integration. And DBT is something that runs on, well, one machine, really, and just delegates actual work to data warehouses. But it submits multiple SQL statements and builds multiple models. And so this is like a quick visualization on what we do in DBT. It's not for every model, we emit a start and complete, and like for the whole execution, we emit start and complete. So if you process like 3 models in one DBT execution, as you can see, we'll emit 8 events, right? The red path like signifies when we actually emit, or not emit, but generate in this case. We emit everything at the end in general DBT integration, but that's where like those events happen. Can I get next slide? So like DBT scales, and in reality, it has like a threading model. You can run multiple models at the same time, as long as it fits like their internal DAG dependency model. If the models depend on each other, of course, the one that is being depended on has finished first. So we still model it the same way, but there can be multiple of them, right, running at the same time. Can I get next slide? And recently we added new model, new like integration, let's say, new option. Basically, it overhauls how we process those DBT events. It relies on the structured logs feature, which allows DBT to emit those events on runtime, and we can basically process them as they are created. But what we also do is we have higher granularity. That means that one SQL model in DBT is not actually a one SQL statement, right, that does something and is the end, right? It's a transaction. And the transaction in general has the structure of we open the transaction, which is a SQL statement of itself. We create table as select the new temper table, which is the end result, really. Then we alter the old table to like append the backup to it, basically. we alter name of the new table to the name we want, which is like this swap process. We commit that, and only then we drop the backup table. So this means for each model, we also have 6 SQL statements, and we emit an event, start and complete event for each one of those, which means 12 additional events for each model. And dbt can also run an incremental model. So that means like there is not much to do. As you can see, like there is a time, and it can take a second, right, to update 12 models. That's not a long time, right? So the sequential execution model of the HTTP client stopped being very well. So like imagine there is 100 millisecond delay for every event, for emitting every event. We have well, like over 100 of them will take 10 seconds at least to send those events. And this takes a second. That's already not good. We shouldn't be that slow, right? Can I get next slide? In practice, I've tested this, and with 10 models and very low data, I got 182 events. Tested it on like basically slow but believable backend. It took nearly 30 seconds to emit events, while the job took, let's say, less than 2 seconds. And in actual real case, we saw a dbt job that tried to emit over 14,000 events. And this took over 30 minutes and didn't finish, actually, because it was killed by an Airflow scheduler. So we can see that we need much better HTTP client than what we have right now. So can I get next slide? And there are like 2 things we could do. One is to batch events, but we don't have that well defined in spec, right? We could change the spec. That requires work on consumer side, right? If it is a much bigger problem because everyone has to implement that, and possibly we have to either have some discovery mechanism for the consumer to see whether it supports that, or there is a lot of possibility of like breaking compatibility and stuff that possibly will be worse than just doing what we want to do in a second point. And of course, the batching also has inherent complexity, like controlling a batch size too large batches, consumers have problems, but also we can emit events in parallel, right? That's nothing in spec prevents us. And Java client already uses thread pooling, and Java has much better thread handling than Python right now, although like maybe newer versions of Python it will not be true. So I chose this path. And can I get next slide? And like in Python specifically, the native solution, since like Python 3.4 or something, is to use async schematics rather than thread pooling. And the first iteration was pretty simple, just queue events to be sent in one thread, while have a single event loop in the second thread that would just get those events, execute them asynchronously, and handle the retries, error handling, logging in the asynchronous path, right? There is some inherent complexity, which means we don't want to send complete event before start event is being emitted, because this could cause, it's some out of order problems. It's not a guarantee, right? Because consumer doesn't have to process it, actually. Consumers can send the data to Kafka or something, but this is a pretty cheap thing that we can do on a client to have at least basic guarantee. So we have in-memory like run ID map. When we complete a start event, complete sending a start event, we get 200 or something like that. We put it there. And if we get a complete event and we don't see a that start event has finished, we just send it to a pending events. Like I said queue, but it's actually a dictionary. And if we complete the start events, we just schedule those complete events or backup, right? We capture some stats also. So we know how many completed and failed. And and there is like queue size control, how many events are emitted at the same time, bunch of like features like that. And it's not yet released or even submitted. There's small amount of cleanup work that I want to do on this. And it changes the transport interface in one way. So right now, you would receive an error if the sending event failed. It's not possible with async interface, right? Because we just put the event into queue, internal queue, and that's it, right? So there is a method that would just return true for non-async interfaces, and it's like wait for completion, and it returns only errors that happened if they happened, or returns nothing if there were no errors. And you can put a timeout in there, and it will like shut down the machinery if it's not done by timeout. So we don't like hang up infinitely if something happens. That's the basic mechanism. And so for that 182 event example, instead of taking like 30 seconds, it took, I think, half a second more than the execution, so like 2.5 seconds. And the biggest cause is the pending events queue. If we don't have to wait for start events to finish before we start sending complete events, it's actually instantaneous, but it introduces a bit of delay. Still think it's worth to do this way. And yeah, that's the feature. So if you have any questions, let me know and comment on the PR when it goes up. And of course, this is like not a default behavior. You have to enable it in config. I think the DBT integration, structured logs integration, will benefit from enabling it by default, but maybe this is not something that like Airflow, where it works pretty well right now, or other Python integration specifically need right now. Maybe we will go that way in when we know it's safe and have more data to show that it's a better way. But for now, it will be a great fit for DBT. Yeah, thanks.
Thanks, Maciej. Any questions or feedback on the approach?
So if you never get a start event and you only receive an end event, does that mean you'll never send in anything for that event?
That's fine assumption in like if you're writing a backend, right? But in this case, we actually don't have that. I mean, we don't have that problem in DBT, but sure, like the solution would be to track if the start event was already, so instead of a set of run IDs, we can have a map of run ID to status, right? That's a good point. Yeah. Yeah, so that solution would be to only do this control if we actually had a start event. It's not possible.
But you don't actually run into this scenario in DBT?
No.
Okay.
Yeah, but I assume once we add that to the Python client, other users who see this might run into these situations.
Yeah, sure.
Should kind of document it.
Yeah, or also like I guess there can be a instance where the you emit complete event from different machine or place where you emitted start event, right? And for sure that would be useless in that case, right? So yeah, have to keep that in mind.
Okay. I guess we can open the discussion. Mike, I'm interested.
Sure. Yeah, so I know I have mentioned before on this meeting that there's been some discussion about integrating OpenLineage with the Iceberg catalog. And I know that there was some work on Gravitino done some time ago. And we have an issue open in Polaris, which is an alternative Iceberg catalog project. But now we actually have some resources at Snowflake that we'd like to, so we would like to do some work integrating with OpenLineage. We're trying to, expand our support for, collecting lineage information for external engines, right? So like we already have obviously internal lineage for Snowflake tables, but we're missing out for Snowflake managed Iceberg tables and open catalog tables. So we kind of want to work on that as well. But I thought we'd go ahead and just have the discussion about what you guys envision integration looking like. We talked about a few different possibilities. One being, Polaris being a proxy for OpenLineage events and being able to kind of augment the payload. Since Polaris has a lot of information about the data set and the current status of the data set, and about the specific snapshot that's being processed or being written, and all kinds of other useful metrics with runtime information. The alternative was to establish a set of like standard APIs that OpenLineage could use to collect some context information. Some of the useful things I think that would be in there would be like user information, since Polaris has concept of user identity and roles and privileges, as well as specifics about like access control and fine-grained access control, view definitions, and like we want to there's a concept of like secure views being introduced, which would be super useful context to have in Lineage. And gosh, there was a third alternative, and I don't remember what that one was. But
Just sending
anyways,
the events, maybe.
What's that?
Just sending the events, maybe. When something accesses.
Oh yeah. So yeah, having Polaris itself send lineage events like independent from the run. And so like you could send dataset specific events to like Marquez that has like contextual information, though we lose out on the runtime context like the user information. So, but yeah, those were the three alternatives that we discussed.
I feel like having the first option maybe, like, or what was it? I don't remember whether it was first or second. The one where you have the like metadata exposed about some particular query or datasets also possibly would allow like Spark integration and maybe Flink integration. And I'm not sure what's the like biggest Polaris user in terms of those processing engines. But those integrations could fetch that data and incorporate them into their own events pretty easily. While I'm not sure how easy it would be to set up the proxy for a regular user, right? Maybe that would include like additional work on the OpenLineage to maybe detect that and use it like as a transport when sending the events. Not sure what the mechanics would be, right?
Yeah, I mean, I was thinking like, we have already the OpenLineage proxy server. So you just set the OpenLineage URL to that endpoint, and then it's up to the catalog to be able to proxy it to whatever your ultimate destination is, right? So if you had like a Marquez backend, you'd have to have Polaris configured to talk to Marquez, whereas Spark itself would only be talking to Polaris.
That might be, well, I guess it depends on where Polaris is usually running in customer environments. And if it's like on the same network as where the Spark jobs.
I mean, it has to be because Spark has to
Mhm.
talk to Polaris, right? The other way around might be the question, right? Whether Polaris can talk to OpenLineage consumers.
Yeah, that's the part I'm more worried about, right? Because what's the egress point for Polaris in relation to where your OpenLineage backend is? But maybe that's fine.
Mhm.
What I'm kind of thinking about why not have both.
I
Or like,
mean,
which one
not all three, maybe.
Yeah, not all three, maybe.
No, I feel like having an API for metadata, right? Just whether it's OpenLineage that wants to call it or maybe something else, right? Would be super useful for users.
Yeah.
And the proxy method, I think for some users would be super useful and some would be maybe less useful because they have to set up additional things, security, connectivity. But if they have that, it would make it easier, I think, for them. So my vote would be to expose an API, just because I think everyone would be able to use it. Like lower barrier to entry, probably. But I don't think we have to. It's not exclusive, maybe.
Yeah, we would just so it would just involve like coming up with a standard set of APIs, and then and I don't know how specific to Polaris the OpenLineage integration code wants to be, right? But I mean, we could kind of certainly establish a set of APIs and then kind of encourage other catalog implementations to implement those same APIs. But
how specific data has Polaris compared to other catalogs is maybe the question, right?
Yeah.
Because they are not obviously equal in terms of capabilities.
Sure. Yeah. And obviously, like Polaris implements all of the standard Iceberg REST APIs. So things like load table and list tables and like you can get catalog properties, you can get namespace properties. But there are specific there's specific functionality that Polaris has that other or other catalogs don't have, or at least aren't standardized. So for example, like just the OAuth endpoint is a standard endpoint, but how the identity or authentication information is not standardized, right? So we have our own concept of principals and principal roles. We have a concept of privileges. We have, and there are things like catalog federation where we can actually kind of proxy other catalogs and actually fetch downstream catalog information, but that's not standardized and there's not a standard way to expose that information either.
That's another point, right? How will we make, is that data that we want to expose actually accessible to any user? Like if you can read a few tables, will you be able to access metadata about those tables and maybe that execution when you call it from the Spark job, for example? Like, is this something that we might have a problem with?
Sorry, I didn't follow that.
So let's say you have enough permissions to query a few tables in the Spark job that you're running. Would you be able to call this this API that we are thinking of and get actually the full runtime information that we think of exposing using the same API key or however the color is identified, right? Can we have a situation where we can't access this information, but we can run job?
No, I don't think so. Because so in order to have table read privileges, you have to have table metadata privileges as well.
Okay,
So you
that makes sense.
can't read a table without being able to read its metadata.
That makes sense. Yeah.
Yeah, and it's largely because of the way that the Iceberg REST protocol actually fetches table metadata to begin with, is because like so when you try to read a table, you actually just fetch the table metadata from Polaris, and it gives you all the table properties as well as the storage credentials to actually read the table data. So but it's not going to include it's not going to include some contextual information. So for example, right, like if you if your Iceberg table happens to be backed by a Snowflake table, right, Polaris is going to return to you just the Iceberg table metadata structure. That is the standard structure with its own identifier, as well as like the table properties, etc. But it's not going to tell you that actually this is a Snowflake table called, XYZ. And that's kind of some of the information, the contextual information we'd like to include in the lineage, right? So that way, when you write to that Snowflake table from inside of Snowflake, and then you read from the same table from Spark using Iceberg, we can generate lineage that shows, that's actually the same table.
That feels to me like we have a way to actually design this API and have this generic part and like Polaris specific, because if it's an Iceberg data, right, it should be always accessible. You shouldn't, we shouldn't have, it shouldn't be like Polaris specific, right? But then also this other type of data, right? The Snowflake connection could be in Polaris facet or something like that.
Yeah, so I mean, we could do something like say, create a facets API in Polaris where you submit a dataset name and we return to you the dataset facets that we want to include. And that would, but and again, right, similarly, we would include other runtime information in the facets, but we would just have to agree on a set of APIs that OpenLineage is going to call, and then have to figure out how to configure OpenLineage to know that, hey, this is actually a Polaris catalog, and not just some, generic
we know this
Iceberg
in
REST.
Spark, for example. Yeah, usually. I mean, if you just use the REST, yeah, I think if you use the REST, we don't know. Yeah, but
Right.
there are some specific, right? If you use Glue or JDBC, we know it's Glue or JDBC.
Yes, if you're using one of the older Iceberg catalog implementations like JDBC or Glue, you're going to know. But the Iceberg in general is moving towards just a REST client, and then having the REST implementation on the server side be completely agnostic, right? So from the client side, it has no idea if it's implemented by Glue or if it's implemented by Polaris or Gravitino or any number of other Iceberg REST implementations, right? So Iceberg wants to kind of focus on defining the spec, but not actually implementing the server anymore.
So that pushes us to like try to standardize,
right?
And maybe in that case, I'm actually kind of curious on like what the API would look like from the Polaris side, and hopefully for everyone. So like maybe the API is like you receive an OpenLineage event to enrich, right? Or like some, and maybe it's not exactly OpenLineage, but like something in the OpenLineage spec that we can send out as like a lightweight event.
Seems you have to identify the point of time, right? Or version that you're asking of this data set, because it can move fast. So there needs to be some temporal component to that.
Is there?
And we'd have to. So I think it would have to be Iceberg specific. So that way you could include things like the snapshot ID and as well as the data set ID. But yeah, so yes, I think if we come up with a standard set of APIs, we could have like the Spark and other integrations call this API with some information. Polaris and other IRC catalogs can return a standardized response with a list of dataset facets and or runtime facets. And at that point, we could kind of augment the payload on the client side.
Is there a good community on the Iceberg side to like get people interested in like defining this API?
I mean, so yeah, Iceberg has its dev mailing list, which is where all major conversations have to take place because it's an Apache project. And you know, if it doesn't happen on the mailing list, it doesn't happen. So that would be the place to bring it up.
We know at least one PMC that unfortunately left the meeting.
What's that? Oh, yes. Yeah. Yeah, we could definitely ping him on Slack or on email. And then within the Polaris community, there is a separate mailing list. And then of course there are Slack channels for both.
Okay, so yeah, maybe we start with the proposal and then we get feedback from that group.
Okay. All right, great. Yeah, so what I'll do is I will sync with the other developer on my team who's kind of leading this project. And I will have him start working on a proposal for a set of APIs, and then we can, and then I will have, and I'll bring up the topic on the mailing lists for both Iceberg as well as for Polaris. So there's not an OpenLineage mailing list, right?
No, we do things on GitHub only.
Okay. All right.
Or
Well,
in
I'll bring it
Slack.
up on a Slack
And
channel then.
Slack, yeah.
Yeah.
But
Okay.
Slack should really be for like syncing up, and then we should document in GitHub because we don't pay Salesforce.
I mean, you can find out useful stuff from issues from 4 years ago, while this is impossible in Slack. So yeah.
Sounds good.
Cool. Technically, Michael Robinson did set up a Slack archiver, but yeah, it's not straightforward to use. So we should keep to GitHub discussions.
Sounds good. All right. I'll work on that then.
Cool. Thanks for bringing it up, Mike. All right. Any other open discussion items? Okay. Giving everyone 14 minutes back into their day. This was awesome. Thanks for joining. Great discussion. Thanks for preparing the presentation, Maciek.
Great.
Yeah.
Thank you.
Thanks,
See you all.
folks.
Bye-bye.
Good to see you all.